We often talk about the importance of batteries for our future and for good reason. Grid storage, for renewables, electric vehicles, boats, it's all going to need batteries. But when we talk about lithium-ion batteries, we usually talk about the cathode. Thinking lithium, nickel, cobalt, yeah, those are all the cathode materials. The other half of the equation is the anode, and here, graphite reigns supreme. But what if I told you nearly all the battery-grade graphite comes from China? That's a really precarious position to be in, and one that could see EV production grind to a halt, all because of this. Hundreds of future EVs will drive huge demand and put a strain on supply chains. Plus, unlike gas cars, China is poised to be a major EV exporter, so they could focus on domestic graphite supply and reduce exports. That's why we decided to fly out to Quebec, Canada to meet with Nouveau Monde Graphite, a promising new graphite mining operation poised to be one of the first in North America. They will be crucial for companies like Tesla and their plans for a North American supply chain. They are also setting the benchmark for the future of sustainable and responsible mining, and even partnering with Caterpillar to run on next-generation electric mining equipment and heavy machinery. So sit back and relax while we talk about the wonder that is graphite on this deep dive today on Two Bit da Vinci. Graphite is a wonderfully ordinary thing, something you've had experience with almost daily since you were a kid. If you've ever used a pencil, yeah, that's graphite. No, pencils don't have lead, and you should be glad. Graphite is a natural form of carbon. Interestingly, diamonds aren't all that different. In diamonds, one carbon atom is bonded with 4 others to create a dense cage-like crystal structure that makes it one of the hardest materials on Earth. In graphite, one carbon bonds with 3 others to form flat layers that can easily slide past one another. This is why pencils have that nice, smooth, ride-on ability. So where does it all come from? It turns out it's mostly mined from regions with high graphite deposits, or it's created synthetically in the lab using calcium petroleum coke and coal tar pitch as its starting ingredients. I feel covered in soot just saying that. Plus, the process is also very energy intensive. The future will require a mix of both synthetically created graphite and also mined, but in this video, we're going to focus on the mining side of things. And how deep are you mining down to?
Now the mining plan is 200. The deepest point is probably 240 meters.
Yeah, just about 240 meters, and the width is about maximum 400 meters wide, average around 370.
Okay.
And again, that's something that will evolve during the life of mine, depending on the economics, graphite prices and all that, because right now we have not hit the bottom of this deposit. So we've drilled down to 350 meters deep. There's still graphite. The body is sort of tabular, not really vertical, a bit at an angle, but we're still hitting graphite at depth. For economic purposes, like Eric mentioned, we're stopping at around 280.
The main reason we are highlighting Nouveau Monde Graphite in this episode is because of the importance of something so simple as graphite for the future of EV proliferation, and second, to talk about the future of sustainable, conscientious, and environmentally friendly mining. Let's start with the graphite, batteries, and EVs. As I mentioned, when you're thinking about elements found in batteries, you're probably thinking about lithium, nickel, and cobalt. The cathode then gives you energy, but that energy needs to be held somewhere when charged, and that's where the anode comes in. And in the anode, graphite is king. The electric potential of storing charge by moving lithium ions into the anode is what gives batteries their capacity. Now, there are some really awesome advancements happening by introducing more silicon into the anode to increase its energy storing capacity. But I actually have an entire video planned on this, so subscribe and stay tuned. Graphite forms a very stable structure to house these lithium ions. Plus, it's a great electrical conductor, making it just about perfect as a battery material. And so once you extract, the deposit, what are the next steps in terms of like processing or refinement?
The first thing is to crush the rock and then grind it and float. You use flotation cells, so you use the properties of the graphite to be hydrophobic, so it floats at the surface of water, and you just scoop the graphite, and what is remaining at the bottom of the flotation cell is garbage. It goes to the tailings, and then you do that multiple times. It goes to Bécancour after for the anode material per se transformation, because this is not battery grade. That's not. If we want we would need to sell our flakes into China, so they transform it. So we decided to do our own value-added processing as well. So here we have the permit to mine 40,000 ton of ore and bring it to our flotation circuit to produce about 2,000 ton of concentrate out of it and qualify it with customer. And then we bring back the 38,000 ton remaining of tailings in the other part of the site that we'll visit afterward, and test as well our tailing management technique, make sure we find the right parameters to store that tailings forever without before having impact on the planet.
So you said 40,000 tons of ore, of which you get 2,000 tons of graphite?
Exactly, roughly.
And 38,000 tons you have to manage?
Yeah, that's rough numbers, yes. Yeah. At commercial phase, it will be more around 2.2 million ton of ore to produce 100,000 ton of concentrate at the end.
A year?
A year, yeah. So in our case, we need to take care of the iron sulfide. The iron sulfide, if it's let like that without any care, it will cause acid generation. So the iron sulfide will become various things, including sulfuric acid. So you need to make sure this reaction is not starting.
So we haven't hit bottom of our graphite deposit yet. We don't know where it might end up, but we've got more than enough for 25 years, 26 years of mine life to date. So this is basically our mineralization host rock, which is technically called graphite paragneiss. Everything you see on this rock, which is a metallic gray, is actually graphite crystals. This particular rock contains probably around, I'd say, 5 to 6% graphite. It's a bit higher grade than what we expect mining, but it's well within the same range. We expect to mine at about 4.15% graphite in this mine.
Naturally, everything we love in our modern lives, from cell phones and laptops to clothes and handbags, has to start as raw materials. In the case of electronics, that can be aluminum or copper, which is mined, or glass, which is consisted of silica sand, which is again mined, or clothing that requires cotton that is grown, picked, cleaned, and shipped. Nouveau Monde Graphite has a pretty simple vision: become the North American source of mined graphite. But it's so much more than that. They have decided to set up shop in Quebec, Canada, one of the most regulated and environmentally conscious places in the world. This means they're going to have to reverse some of the trends that have typically plagued mining. When you think about mining, you're probably picturing some horribly environmentally destructive operation. And for good reason, mining hasn't had the best track record. But as I've noted, modern lives are absolutely dependent on it. So, is there a way for us to mine in an ecologically friendly way? And if there is, what would it look like?
So on a mine site, it's important that every drop of water that fall on the mine site finish in those ponds that will be treated, and there's only one place, we call it the final effluent. It's where we monitor it closely, we make sure the water is crystal clear before being released to the environment. So that's why you see, for a small pit like that, all the infrastructure that is built, that we're working to. It's to make sure we handle all the water and the tailing properly before releasing it to the environment.
From the drilling in exploration, we take the core and we analyze the rock, what kind of metal we have, and how it could react with water and oxygen. And when we know everything about the rocks, we do some engineering about how we will manage them. Before, in the old time, mining, it was just like, we go, we extract, and after that we will see. And that's why we see some image of mine, where we see oxidized tailing or abandoned mine site, and it's like a legacy, environmental legacy. Now we have to understand, before the reaction start, how we will manage, how we will avoid all that, and we have to present that at the government and all the ministry. So that is tailing, so that comes from the process.
So this is the tailing?
This is the tailing, yeah. We filter the tailing, so we remove all the water, and we truck the tailing instead of pumping the tailing. And it's a small cell over there, but we will do an engineering infrastructure without dam. When you take the ore, the waste rock is the rock that you don't have graphite or not enough, so that waste. But you have to manage it. So that's that kind of size or bigger. It could goes to 1 meter to some centimeter.
Oh, I see.
Yeah.
So the bigger rock that doesn't have any graphite
There's
doesn't go into the
not
further.
enough to go at the process. So we just we just take it from the mine, from the underground, and we go at the waste dump immediately.
But this is, we call it non-acid generating tailings. So we extracted all the minerals in it that could cause an acidic reaction to start.
The long-term plan, yeah, the materials go back to where they
It's
came
not.
from,
It will be during the operation. You plan from the beginning how you will close it, and you do it during your operation. You have the truck and everything on the site, and you could prove that you will do it because you do it during your operation. After years 4 to 5, we will be able to start go backfilling in the open pit, but we don't have enough space to put everything because the rock take more space when we remove. Yeah.
I don't know if you drive an electric car, but when you go downhill, it breaks. So for us, doing backfilling with an all-electric fleet makes a lot of sense because it's a downhill application. So you go downhill heavy, you recharge, and then you have enough when you're empty going back up. So for us, that's why year 4 to 6 is the right time, because all our fleet will be now all electric.
In Quebec, we're responsible for the site even after closure, after the life of mine. Once we're done and we've put the site back to normal and put on vegetation across the whole site, we're accountable for the quality of water, for the infrastructures on site to make sure it's safe for everybody. And Martin has some reporting to do to the government and needs to provide proof that it's safe before we can hand over the site to the government. So we've got all the incentives to put in the right design from the start to ensure that it's safe for the long term. And that was also an ask from the community from the get-go when we started talking and discussing, developing a mine here. It's a gorgeous region, and it's not a community that's used to mining. There were some back and forth in terms of what would make sense in terms of a project, and they said no to dams, and so other solutions were chosen for tailings. But some of those elements helped us kind of guide design and engineering to have the best project for the environment, for the community.
So we see the America today is implementing a lot of rules to make sure that the economy is getting decarbonized, to catch up a little bit on Europe, let's be honest. But now, it's getting there. It's getting there. And to part of this decarbonization is also understanding that 100% of our minerals cannot come from China. And in graphite anode material for batteries, it's 100% coming from China. It's just not sustainable. We need diversification. We need to have low-cost operation that are built the right way, but we will be competitive overall because we do have advantage.
Believe it or not, 95% of Quebec's energy comes from hydroelectric power. This means every bit of mining, refining, and processing will happen with clean, renewable energy. This sits in a stark contrast to the largely coal-powered grids of China, where most of today's natural graphite is mined. I see hundreds of comments bringing into question just how clean EVs really are. And well, I don't take that lightly. It is true that mining practices in countries like China are hard to fully understand. With less regulatory pressure, odds of environmental destruction definitely increase. Nouveau Monde, then, is a truly important company because they plan on setting some of the new standards on responsible mining that may lay the blueprint going forward. And they will be ready to produce roughly 100,000 tons of natural graphite yearly for decades to come. Their efforts will give companies like Tesla an alternative to graphite from China and from synthetic graphite.
I don't know if you see all the silver flakes that tends to shine. This is the graphite that we want to recover into the process. So we're going to take that rock and grind it into sand. The loaders give a bucket every hour inside this feed, and the feed is going into the bucket elevator that brings the material up into the classification screen. This feed screen is cutting at 1 millimeter, so everything that is coarser than 1 millimeter goes into the rod mill. Everything that is finer than 1 millimeter pass the screen and get into this bin and feeds up the hydrocyclone. I don't know if we see it well up there, but It's like the small green cylinder that is over there. This is the ball mill. The ball mill is like, there's iron balls that is lift up inside and hits the rock to get the finest material, as fine as the sand we have saw on the tailing piles. So this is the PAG filter press. His role is to remove water from the tailing, the potentially acidogenic tailing. Here we got the magnetic separator, as I mentioned before. It's a magnetic drum that ferromagnetic particles get stuck onto. The magnetic concentrate goes in this pump, and what is non-magnetic goes in this pump. One nice thing about this process is that 100% of the water is recirculating. Here we don't have any water that goes out into the wild. This is the dryer. There's a filter press on top. The filter press is pushing water through filter cloth, and this is a dryer, so the material gets dumped into this, and it's pushing the water content left evaporate. So this is the bagging system. On top of that, you got a classification screen that screens the material from. You got a jumbo flakes, large, medium, and fine. We split it in 4 different categories. So this is the flakes that is coarser than 300 micron, so 0.3 millimeters. So this is the coarsest product we supply, we can produce here at the demo plant. And this is the finest category, the minus 100 micron, so everything that is finer than 0.1 millimeters.
All right, so this is a micronization spheronization module that we have. It's a phase 1. We've installed it here at our plant, but we'll have this module or a similar one repeated multiple times when we're at a commercial scale in Bécancour. So that's step 1 of the value-added transformation.
The goal of this equipment is to achieve like a point, like a 17 micron of the D50. So 17 micron is the largest market we're gonna have. So this motor is like a turn hammer that breaks the particles into very small, and this motor is a classification wheel. So it's a wheel that turns inside, and there's an air stream that lifts the small flakes, and if they're too coarse, like 50 microns, they're gonna get hit by a paddle of the classification wheel because the speed is too low. So they get back onto the hammer, and when they are the good particle size, they get passed through the wheel, and the airstream get it to the big bin that is up here. There's also a classification wheel on top, like everything that is too fine, like the small particle that is created in this process, goes into a fine bin, and everything that is spheronized gets stuck in this unit. After the time, they push the material with an airstream into those bins, and then they put a big bag on this, and empty the bins inside to ship it to Bécancour. I don't know if you saw it, but this is the material that is coming out of the. So you don't see the grain anymore. Before we were sawing like 100 micron, and this is the 17 microns and less. So it's very, very fine powder. You can touch it, no issue.
Hey, we're right here in Bécancour. So as you see there, we have our chlorine supplier, All-In, is just located across the street from the land we have purchased here to build the phase 2 of the battery anode material plant that we're building here in Bécancour. That's where we'll have the 3 main process steps: a big shaping hall, a big purification hall, and a big coating hall to make all the steps necessary for our graphite to be battery grade. The big advantage of our land located here in an industrial complex, one of the largest in Canada, in fact, is you see our chlorine supplier is located right there. Usually they deliver their chemicals using a rail car, as you see now. And that's where the cost is, and I would say the challenge is in transportation of chemicals. In our case, we will use this pipe rack, and we will receive our chlorine supply using directly a pipeline rather than having to transport it. Also, right at the end of the street, there's a deep sea port, and that's a big advantage also to receive all the reagents and the material, and potentially receive also flake graphite from other sources than our own graphite mine.
Both fluorine and chlorine do not attack carbon, but they attack everything else. Fluorine is very efficient, and this is what China use in most of their process with using hydrofluoric acid, except that this is not readily available and cannot be recycled. So it generates a lot of waste that has to be disposed of and turn the environment into a nightmare. While chlorine is everywhere in your life. It's in table salt, it's in all plastic, it's in all kind of material, and it's very easy to produce. You have to be very careful, all kind of safety procedure, but it's produced using basically table salt as the beginning material. And what our process will do is return that salt that we generate and return it to our supplier of chlorine. One of the big difference between using natural graphite or synthetic graphite, which is one of the big competitor out there. To produce synthetic graphite and you only use the thermal process, you have to go all the way up above 3000 Celsius. You have to use a lot of energy, a lot of electricity. Our process here, using hydroelectric power, we only have to go to 1500 to 1800 Celsius. It's much more efficient. A lot less energy is used, and with the combination of chlorine, that is the taxi molecule really to remove the impurities, and then we can return the chlorine, any excess or any salt generated, to our supplier. That's the key, that our process, we can recycle all of that material back, and the cost will be much less than trying to bring the material to much higher temperature.
So then, we'll need lithium, we'll need graphite, we'll need to bring it all together, build batteries, and then build cars. But how exactly are we going to do it? And how much of everything will we need? What makes supply chains so challenging is the idea of the limiting factor, which is also the name of an amazing YouTube channel that you have to go check out. Links in the description. But the idea is, whatever you have the least of will determine how much of something you can make. Let's say, for example, I have a machine that creates 80 car doors a day. But my machine to create wheels can only make 40 per day. Because each car needs 4 doors and 4 wheels, it wouldn't matter how many doors or body panels or windshields I can make. The limiting factor would be the wheels, capping my output to 10 cars per day. It's the same idea with batteries, where the limiting factor is the raw material in shortest supply.
The battery demand will have a tremendous impact on the natural graphite industry as we see it today. So currently worldwide there's about 1.2 million tons of natural graphite being produced for all markets, including lithium-ion battery, refractory and other niche markets. Now, if we look just at the lithium-ion battery, the demand will exceed 3.5 million tons over the next 10 years. That there are some markets that are getting cannibalized by it. So there will be huge consequences on markets which are already established that are used to buy natural graphite, because all of a sudden they're not going to be competing against their competitors, but they're going to be competing against lithium-ion battery users because all of the material comes from the same feed. And this is what we see as Nouveau Monde as having a key impact into the market. So for Nouveau Monde, the volume allocation is highly critical, as we do not want to rely only on one market. So the decision at the very beginning was to focus on the 3 pillars that we have identified in our marketing strategy. One being for sure the lithium-ion battery, which will capture roughly 60% of our feedstock from the mine site. That will be transverted into 42,000 metric ton of lithium-ion battery grade material. There is another about 15,000 metric ton we will be generated of fine graphite, which will go into niche application. And then the remaining 40,000 metric ton coming from our mine site will go into traditional market like the refractory industry and other niche market which needs large flake graphite, including the fuel cells application for hydrogen cars.
I say this almost every week. The key to a stable future is to diversify our investments. We should build solar and batteries. We should invest in green hydrogen and iron flow batteries. Maybe graphite exports from China continue unchanged, or maybe they don't. We are truly in the middle of a movement now. Electric vehicle companies are flourishing. We have to look at every part of the battery supply chain and continue to increase output on those pesky limiting factors. And if you want to create a stable and sustainable future for Two Bit da Vinci, hit that like button. Sometimes I take for granted how amazing these times are. When I graduated from college, no one was talking about anything but gasoline cars. Then we get Tesla, who showed us how amazing EVs can be. EVs will build millions of new jobs and trillions of new dollars in wealth. Nouveau Monde had the foresight to see this revolution coming and be ready to capitalize. They are ramping up their operations and have some hard work ahead. But with their leadership team and their vision, I expect Nouveau Monde to grow leaps and bounds. Another amazing thing about this company is how awesome their leadership team is. I got a chance to spend a couple days with them, and they're so fun and funny. If you haven't had a chance, check out their YouTube channel. They have some hilarious videos. I actually think they make better videos than we do. I don't know why we're making this video, but anyway, amazing team of cool people. Definitely check out Nouveau Monde. So what do you think? Are you as excited about Nouveau Monde as I am? Are you thinking about investing? What questions do you have about their business? I'm hoping to head back out there to check out their electric mining equipment deal with Caterpillar in the future. So send me your questions and I'll be sure to pass them along. So thank you so much for watching. If you want to be a rockstar supporter of this show, please consider joining us on Patreon or as a YouTube channel member. We call you guys a 2-Bit Tribe. You guys can come travel with us, help us write scripts, pick future video ideas, and just generally hang out and chat with other like-minded people. We'd love to see you there. And there's really just a small monthly commitment. You can cancel anytime. Thank you so much for watching. And as always, I'm Rick with 2 Bit da Vinci. And remember, the future is going to be awesome.